Hello friends and hello student. My name is Ashok Sijala. In this session, we learn the octal number in binary C language. So first I share my laptop screen and fix the position here so you can watch better with my video lecture. And here Turbo C++, I double click and take some process and now yes is open ultra file menu, taking new file, and here our goal, write a program to um, convert octal number to binary number. So here that is what is a input, then what is a process, and then what is a output. So here we can enter one octal number and convert into the binary number. That is our goal. And in between, how to find out? So I think you have to know. So like we can enter one octal number 65. So that is we can get 110 then 101, that is our binary number. So octal number 65, so we can understand both number systems. So octal is 0 to 8, that is our octal number, that is based on 8, and binary is a 0 and 1, so that is based on 2. But we can first that octal number convert into the decimal and decimal number convert into the binary. So that is I already take in the decimal number convert into binary and octal number all decimal to uh, octal number how to convert. So you can watch that video lecture. So here we can directly start to our program in C language. So first I include our header file stdio.h, and then now we can include console input output, and then void main. Yes, so we can start our program, and first we can declare, yes, here we can declare as integer, that is octal, and then that is we can scan and decimal to assign to 0, and then long because that is long that we have to declare like I initialize that 0, and binary, so that is a long integer variable, so we can get our perfectly. So here we can declare as a 4 variable. Yes, here uh, octal, decimal, and first so octal number converting decimal, and then decimal number converting to the binary. So that process you have to know. And decimal number, that also that base is a 10, so 0 to 9. So now I can scan, means that clear screen, and now we can scan first, that is a enter octal. Yes, so yes, octal number, so we can scan, let us check. So that is a integer number, so percentage d, and then I take as o, that is our variable oct. Yes, and now we can first, that I previously say, that is number program we can always take as a while loop. So first we can octal number convert into the decimal number. So that we can take one while loop and plus equal, that is compound assignment operator, and then we can octal number convert into the decimal. So that is a decimal is a base is 10, and here is first that module operator, and then multiplication. So multiply that power, yes, here we can use as power function, and that non-octal is a base 8. So power function require the maths.h. Yes, here can include one header file and math.h. So perfectly. And now we can take as I plus plus, so that is a base upon 8, and we can separate that our octal number to convert in decimal number. So that is a power of I, and then octal we can divide equal, so that is we have to 10, so because we can convert in decimal number. So that is a I just write for here. We can process octal number, or we can say that octal to decimal number. That is a conversion. This while loop. And now we can take as first I, that is again comment line, and now we can decimal. Yes, so we can decimal number to binary number. So that is you have to know. And first I initialize 1, and again I take as while. So now we can say that decimal not equal to 0, and then here also we can take as 3 binary. So plus equal and decimal. So we can decimal that you have to know modulo 2, and then again that multiply I. Yes, so that is our, you have to know very well here, that is a decimal to binary, so that is a base of 2, and then decimal plus equal to divide by 2. Yes, you have to know. And I, that multiplication and equal, so that is a base on 10, because that is a decimal number, so we can multiply that position, get that binary number. So that is a full form. Yes, I think you have to know. Here I write so like decimal equal to decimal and divide by 2, and here that all I write in the compound assignment. So I equal to I multiply 10. So that is a convert, and here that binary, yes, I write in comment line. In previous while loop I also take decimal and octal, that is a compound. So binary equal to binary and plus, so previously that is a store value, and modulo 2, and then multiply I. So that is a same process in here in previous while loop. Here is also short compound assignment. Here is a octal equal to octal divided by 10, so I not write. And now just that finish our process. So there are two while loop here we can use, and now we can say that octal number to binary number is, or you can just, yes, and here we can LLD, long integer, that is, and we can print our binary number. So that is a finish. So let us check how it possible. Now I can save this file. So here we can say that octal to binary dot cbi. So actually we can convert octal number to binary, but first we can octal number convert into decimal, and decimal number convert into the binary. So that is a perfectly. So now yes, there is no any error. So that is a perfect, only two while loop we have to take. And now let us check our 65, that is our I solve in my paperwork. So octal number to binary is a yes, 110101. Yes, that is perfectly. I previously say that is our answer. So how it possibility? So let us check. I take as watch window, and here and also I take as output window, and now I set the watch. So you can just green that green selected span, and here I take first OCT octal, then decimal, then there are four, yes, I and binary. So there are four, two integer and two long integer. Yes, that is very interesting. So now I can trace dry run method. So alter R here trace into, I press F7 function key, and that you can now clear, that is I not press F7 C, but you can see in watch window or output window now is clear. And now our message is print, enter octal number. I again give 65, and now press F7. So here octal is 65, all other are 0. Yes, no any garbage value. So only one is scan, and three is a we can use in our logic. So that is a process. So octal is not equal to 0, yes, and decimal. So we can convert first decimal to octal to decimal number. So that is a 8 upon I. So that is a I is first 0, and modulo that is separate the. So here 5, first separate 5 and store in D decimal DEC variable, and I plus plus. So then 1. octal that divide by 10, so only that 6. And now yes, again while loop is true, then 5 already stored, and now that is a 6 uh, that multiply 8 upon 1, so that is a 53. Yes, and I plus plus, but and then again 10, so that is a 0, so not equal to 0, but that condition equal to 0, so that is a false while loop. And I assign, again I use same I, so I assign I as a 1, because we have two multiplication operations. So multiplication 0, we have to not all are 0 in maths rule, so we can assign 1. And decimal is 53, 65 octal that convert into decimal, so that 53 and 53 that we can get equal to binary number, so that is equivalent to 65 octal as a binary number. So now let us, you can look here, long I why take, yes, that is your, I think your question. So here that very long that out of range was normal integer, that is 65,767, that positive range. But here that bigger number, you can look now here decimal, that is divide 2, and here you can look that is 26. And I, yes, I also I take long integer, so here you can look. So first is I assign now directly 10, that is a position. Yes, and here you can see that decimal 26 and binary is only 1. So now yes, now step by step I, you can look here now that divide by decimal 26 divide 13. Yes, 13 is decimal, divide by 2, and again multiply 10, so 100. Now that not equal to, again that 13 is not equal to 0, so that is a now multiply I and modulo, so you can look 101. Yes, that convert on binary. And now again divide by 2, so that is a 6. Yes, multiply 100. Yes, so I is now again 6 not equal to 0. Yes, now that multiplicate modulo and multiply I, so again that is a divide by 2, so 3, and then 10,000. Yes, again not equal to 0 because decimal is 3. Then again that modulo 2 and I multiply, so you can look in binary 10101. So yes, that is a compound. Yes, you have to look. Yes, and now not equal to 1 decimal, not equal to 0. So you can look I is a out of range, means our integer. So I can take long. Here 1 lakh is there. So 50. So there is out of range in normal integer data type. So I take as a long integer. So now you can look, that is our target is achieved. So 1010 yes, so that is a perfectly. And now I, so here now 10 length, but now that condition is false and our binary number is perfectly achieved. So that is a process, so I take as a long integer. So I think you have to understand. So yes, here that the first multiplication, yes, that very important in, that is a, we have to use as a two operand modulo and multiply I, and then again store this binary and then divide by 2, because we have to base is a binary is 2, and that position we can get multiply 10. Yes, so that is a perfectly. So now you can give any number. So now I can octal number give the like 1025. So that is a, that octal to binary number. So first that convert in decimal number, and then that decimal number convert into the binary number. So you can take in yourself as a watch window and observe your analysis. So now, yes, I hope you can understand. So octal to binary, how to convert in C programming. So first you can convert octal to decimal and then decimal to binary. So there are two while loop you have to take, and very short logic I develop. And now I think also you can understand why I can take two long integer, because that is a bigger range of integer, normal or long. So here 2 time long integer. So LLD, that is a, I think you have to first see in LLD, that is a formatting symbol for long integer. So 2 time L long integer. So yes, I think you have to write this C program to your C notebook. If you prepare any doubt or any question regarding this definition, so you can write in comment section. Now I can close Alt F3 function key, close this file, watch an output window and quit. So subscribe my channel Ashok Srijal Academy, press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.